An electric kettle has two heating elements. See, electric kettle means it's basically a heater which can be represented by a resistor. This is heater 1, this is heater 2. One boiling the water in T1 time. One boils in T1 time, the another one in T2 time, and both are having same heating effect. This gives heating effect, the same heat at T1 time, this gives same heat at T2 times. This is kettle number 1, kettle number 2. Find T taken by the water to boil when heating elements are connected in series first. When we connect in series, when connected in series, these both are now connected in series. These both are now connected in series. Connected in series. See, we know heat produced is equal to V square by R, that is power into time. H is equal to R. From here, R, what we can write? R is equal to V square by H into T. Since H is common for this one, so heat produced, the first one, R1. R1 is equal to V square by H into T1. V square, because applied voltage is, total net voltage is same applied, and R2 V square T2 divided by H. When both are connected in series, so when both are connected series, R is equal to, R equivalent is equal to R1 plus R2. R1 plus R2. So what is the net heat produced? Net heat produced is equal to applied voltage into T divided by R equivalent, that is R1 plus R2 is equal to V square into T. R1 is equal to V square by H. V square by H T1 plus V square by H T2. So V square by H into V square by H2. When what is net heat produced, that is H, is equal to V square H, we can take common out, and so V square T into, we take this one up, this becomes V square into 1 by T1 plus T2. This I have taken out, common term we have taken and reversed it, H by V square into V square T into, okay, this get cancelled. So this is H, this H and this gets cancelled. It means 1 is equal to T by T1 plus T2. That implies the total time taken is equal to T1 plus T2 in series. When connected in parallel, this is R1, this is R2. Kettle number 1, kettle number 2. As it is, we know the value of R1 is equal to V square by H into T1, and R2 is equal to V square by H into T2. Now, what is the heat produced? Heat produced is equal to V square by R into total time taken. This is the power into time. Here, since both are in parallel, these two are in parallel, we net heat connected is equal to V square H RT by P. R parallel. What is R parallel? This is in parallel. Therefore, H is equal to V square T into R parallel, R1 into R2, that is V square by H into T1 into R parallel is R1 R2, V square into H divided by into T2 into R1 plus 2, we can take it on the top, that is R1, V square H we will take common into T1 plus T2, we can take it both as common. This V square H, this V square H we can cancel. this V square we can cancel. Therefore, H is equal to T into T1 plus T2. T1 plus T2. This H will go on the top, H, and divided by T1 into T2. So this and this we cancel, or T is equal to T1 T2 by T1 plus T2. A cell of EMF epsilon naught, that is cell, this is a cell with the internal resistance, EMF internal resistance R, supplies current for the same time. So it means T1 is equal to T2 is equal to T through external resistance R1 and R2. First this cell, this is first cell, through external resistance R1, this is our EMF, and second, and through the another external resistance EMF or same cell, another this one R2. Separated if the heat produced in external resistance in two cases are same. It means this produce a heat of H1, this produce a heat of H2, and it is given H1 is equal to H2. As it is, we know H is equal to I square into R into T, H is equal to. So here where I is equal to current, what is the current? Epsilon by total voltage divided by total resistance and R1. We can write it for H1. What is H1? H1 is equal to I square, that is EMF is same for this one, R1 plus R into T1. T1 R1 into R into R, that is R1 into T. What about H2? H2 is equal to same EMF, the external resistance are different but internal resistance is same, into R2 into T, and it is given H2 is equal to H1 and T1 is equal to T2 is equal to T. So when comparing H1 is equal to H2, that is epsilon naught by R1 plus R into R1 into T I square is equal to epsilon by R2 plus R T and whole square into R2 into T, cancelling this to 1, and we can cancel this and this also. This equation becomes R1 divided by R1 plus R whole square is equal to R2 divided by R2 plus R whole square, and expanding this one, R1 into R2 square plus R square plus 2R1 R2 R, this is equal to R1 into this one is equal to R2 into R1 square plus R square plus 2R1 R1 R, and adding this one R1 R2 square, R1 R2 square plus R square R1 plus 2R1 R2 R is equal to R2 R1 square R2 R1 square R2 R1 square plus R2 R square plus 2R1 R2 into R. Now we have to separate out this one. See, this 2R1 R2, this and this term will get cancelled. So we take the R outside. That is, from this R square, we take R outside, R R square, this term we will take R square R1. When we take this term this side, that is R2, these two we have taken out, rest of this get cancelled. Rest we will take it R1 square R2 minus R1 R2 square is equal to, we take R1 R2 out, that is R1 minus R2. So this is R square into R1 minus R2, cancelling this and this, R square is equal to R1 into R2, or the internal resistance is equal to under root R1 R2, under root R1 R2. So where R is equal to internal resistance, internal resistance of the cell.